for launch. FTS.
FTS go.
Prop go. AVI.
AVI's go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Good morning and welcome to SpaceX's live coverage of the ViaSat-3 Flight 3 mission for our customer, ViaSat. SpaceX's Falcon Heavy rocket is set to lift off at 10:21 a.m. Eastern Time from Launch Complex 39A at Kennedy Space Center in Florida. I'm Tyler Lionquist, a Starlink business analyst.
And I'm Amanda Yares, a ground systems engineer. Thank you for joining us for our 12th Falcon Heavy mission. Weather continues to be a watch item this morning with 55% favorable conditions, and we are tracking no major issues on vehicle or payload at this time. If needed, we do have a backup opportunity tomorrow, Tuesday, April 28th at 10:17 a.m. Eastern Time.
Falcon Heavy today is launching the third of 3 ultra-high capacity satellites for ViaSat. Once in service, ViaSat-3 Flight 3 is expected to provide more than 1 terabit per second of broadband capacity over the Asia-Pacific region, more than doubling the bandwidth capacity of ViaSat's entire fleet of satellites, and completing the ViaSat-3 constellation. So while the countdown continues, let's take a moment to learn more about ViaSat.
We're really excited today for the launch of ViaSat-3 Flight 3, which is going to bring unprecedented amounts of bandwidth to the Asia-Pacific region. So ViaSat-3 is a really good fit for Asia-Pacific with our forward-looking plan for these multi-orbit systems.
Asia-Pacific's a really important region for Viasat. Of course, we have a significant body of customers in the maritime space, and we've got an established stable of aviation customers as well.
Deploying the ViaSat-3 Flight 3 satellite operationalizes our partnership with Australia. This region is going to be extremely valuable for Viasat and our allies going forward.
Once Flight 3 is in service, it is designed to provide significant, secure, highly flexible connectivity across land, sea, and air.
ViaSat-3 is designed to deliver multiples of the amount of bandwidth that we have in the Asia-Pacific region. The beamforming capability of ViaSat-3 is really going to be valuable. The ability to put bandwidth just where it's needed, when it's needed, in serving ships and airplanes especially. And then we're working on new forms of beamforming that build on what we did for ViaSat-3, but that will allow us to do that in much smaller capital increments, drive bandwidth costs down, and give us increased flexibility.
It is designed to add more than 1 terabits per second of throughput capacity to our network. This includes the Five Eyes nations of Australia and New Zealand, regional markets such as Singapore and Malaysia.
We're expecting great things from Flight 3, not only in serving our existing customers at sea and in the air, but also opening up new opportunities, providing capacity and coverage over remote areas.
The ViaSat-3 Flight 3 satellite is designed to provide secure, resilient connectivity. We're going to be able to show our government customers and prove to them the resilience and capacity that these satellites were designed to provide.
26 is a big year for Viasat. We're bringing 2 more ViaSat-3 satellites into service that are designed to more than triple our bandwidth. We're excited about our opportunities in the future. With validation of these beamforming capabilities, what we're really doing is just getting started on what the potential for that is.
I'm incredibly proud of the many years of dedicated work of an exceptional team on the ground and around the world.
I just want to extend a heartfelt thank you to everyone that gave so much to make these satellites real.
You know, there's a ton of hard work that goes into preparing satellites for launch, but there's nothing more exciting than watching it actually happen in real time. So enjoy the launch.
It has been a little while since we've seen Falcon Heavy on the pad, and what a sight it is. Falcon Heavy was developed entirely by SpaceX as a heavy lift version of our proven Falcon 9 rocket. Its debut flight in February 2018 marked the first time a rocket this powerful had been sent to space by a private company.
Falcon Heavy is essentially 3 reusable Falcon 9 first-stage boosters connected together, with the center core modified to withstand the stresses of the side boosters. This super efficient design features the same Merlin engines, avionics, and systems that have flown hundreds of times on Falcon 9.
The first stage is comprised of 3 cores with 27 engines across the 3 first-stage boosters and a 28th engine, a Merlin vacuum or MVAC, on the second stage. The side boosters are connected at the nose cone, the interstage, and octaweb structure at the bottom of the vehicle.
Falcon 9 is the most launched rocket in the industry today, handling the majority of SpaceX missions, including Starlink deployments, crew and cargo flights to the International Space Station, private astronaut missions, and most commercial satellites. Falcon Heavy delivers significantly more performance for missions that require greater payload mass or higher energy orbits than a single Falcon 9 can provide, like today's ViaSat payload. As one of the world's most powerful operational rockets, Falcon Heavy is capable of launching nearly 64 metric tons, or 141,000 pounds to orbit.
And that's why Falcon Heavy is primarily used for large commercial communication satellites, national security payloads, and major NASA science missions, like NASA's Griffin Lunar Lander and the Nancy Grace Roman Space Telescope, both manifested for late 2026. Just earlier this month, NASA announced that Falcon Heavy has been selected to launch the Rosalind Franklin mission, targeted for 2028. And this will be the first Mars rover to search for life on the red planet's surface.
And it makes one heck of a Matchbox collectible.
Sure does.
To date, Falcon Heavy has flown 11 times with 100% mission success. Its first flight on February 6, 2018 was a demonstration mission that carried a Tesla Roadster and Starman into a heliocentric orbit around the sun.
I will never forget watching that simultaneous recovery of the 2 side boosters for the first time. It was totally unbelievable, and it's something I know we're all looking forward to from Hawthorne today.
You know, it was actually the first launch that I ever saw.
Wow.
And I remember distinctly the feeling that the future is now.
And speaking of that 2018 flight, I checked on Starman's whereabouts recently, and the Roadster is still out there orbiting the sun.
As he should be. And after that unforgettable demonstration flight, Falcon Heavy moved on to operational missions. In November of 2022, USSF-44 became the first classified national security launch on Falcon Heavy, placing sensitive payloads into high-energy orbits. And in 2023, Falcon Heavy launched the ViaSat-3 Americas mission. Then the Psyche mission, which launched later that same year, sent NASA spacecraft on a journey to study a metal-rich asteroid, providing valuable data on planetary formation.
And Falcon Heavy's most recent flight in October 2024 carried
Center
NASA's...
core RP1 load complete.
There we heard good confirmation that the center core first stage has completed RP1 load. That LOX load is still underway. That most recent flight, 2024, carried NASA's Europa Clipper spacecraft toward Jupiter's moon Europa, and the mission required the full performance of Falcon Heavy to achieve the necessary escape trajectory. That brings us to today's mission, with Falcon Heavy poised to carry the ultra-high capacity ViaSat-3 Flight 3 satellite to orbit. We'll continue to hear those callouts as RP1 loading wraps up on the side boosters over the next few minutes.
Like Falcon 9, Falcon Heavy is a 2-stage launch vehicle.
Falcon Heavy's 27 Merlin 1D engines together generate more than 5 million pounds of thrust
RP1 load complete
at liftoff, and that is the confirmation that one of the side boosters has wrapped up RP1 loading. That thrust is equal to approximately 18 747 aircraft. Shortly after liftoff, the center core engines will throttle down, and after the 2 side boosters separate, the center core engines will throttle back up to full thrust.
Starting from the very top of the rocket, we have the payload fairing. The fairing is a protective shell that houses the payload, shielding it from aerodynamic heating until the vehicle
Engine chill has started.
is outside of Earth's atmosphere. The shape of the fairing contributes to Falcon Heavy's overall efficiency, helping to reduce drag during flight. And once in space, the two fairing halves separate and fall back to Earth for an ocean landing, where they'll be recovered by our recovery vessel to be refurbished and reused on future flights.
Both halves of this fairing are flight proven, with one side flying for its 25th time and the other for its 18th. And within that fairing is today's payload.
NY RP1 load complete.
The other side booster has wrapped up RP1 load. ViaSat-3 Flight 3 arrived in Florida in April to begin its pre-launch preparations and checkouts before being mated with Falcon Heavy's second stage. Here is a photo from midway through the encapsulation process. This is just before the fairing halves were closed in preparation for flight.
And here's a live view inside the second stage as we await liftoff. Now, right below the fairing is Falcon Heavy's second stage, which houses the MVAC engine. Below the second stage is the black carbon composite interstage, and inside of that is where the MVAC engine is located. The interstage connects the center core on the first and second stages and holds the release and separation system.
And below that, we have those three first-stage boosters that we've mentioned, which make up the bottom two-thirds of the vehicle. These side boosters supporting today's mission are both flight-proven, with one flying today for its 22nd time and the other just for its second. One side booster previously supported the SDA-0A, Sarah-2, Transporter 11, and 18 Starlink missions, and the other supported the GOES-U mission. As mentioned earlier, about 2.5 minutes into flight, the side boosters will separate and make their way back to simultaneous landings at Landing Zone 2 and Landing Zone 40 at Cape Canaveral Space Force Station.
Now, next up, the
Falcon Heavy tanks are pressurizing for strong back retract.
There's a good call out. So we're expecting soon, within the next minute or so, that strong back to slowly recline away from the rocket. So that truss structure next to the vehicle is called the transporter erector, which is also called the TE, or the strong back by the launch team. In preparation for retraction, those clamp arms around the second stage will open, making way for the transporter erector to move away from the vehicle. That TE is designed to transport, raise,
Strong back retract has started.
and support the rocket at the launch pad. So in a few seconds here, we'll start to see those arms, those clamp arms underneath the second stage start to open. And it's going to take about 15 seconds for them to fully open. But then once they're out of the way, the strong back is free to recline away from the vehicle and give it room for liftoff. And you can start to see those clamp arms opening now. Now that those arms are open, the rocket is fully free at the top.
NY LOX load complete.
There we heard the call out that one of the side boosters is now complete with its LOX load, so it's fully loaded with all of its propellants. We can see that strong back slowly start to retract away.
LOX load complete.
And then we heard the call out that we are fully loaded with LOX on the other side booster. Now, as we mentioned earlier, this is our first Falcon Heavy flight since 2024, and a lot's going to happen in the first 4 minutes of flight. First, we'll light the two side boosters, followed by the center core. Then about 40 seconds after liftoff, we will decrease power on the two side boosters in preparation for max Q. At about 2.5 minutes into flight, the side boosters shut down during the booster engine cutoff, or BECO, and the boosters will separate. Once clear of the side boosters, the center core will throttle up once again until the center core shuts down with main engine cutoff, or MECO.
Center core LOX load complete.
And there we heard the call out that stage 1 LOX load is complete, so at this point in time, both side boosters and the center core are now fully loaded with liquid oxygen. Meanwhile, those side boosters will complete their flip maneuvers and boost back burns, making their way back to Earth for recovery. And then the first stage will separate from the second stage around the 4-minute mark, and the second stage will light its engine, and the fairing will separate.
We're coming up on our last milestone of propellant loading, which will be the completion of second stage liquid oxygen loading. Propellant load has been underway since the T-minus 15-minute
Stage
mark.
2, LOX load complete.
Right on time, and with that, liquid oxygen has loaded on to stage 2. Falcon Heavy is fully loaded with nearly 3 million pounds of propellant. Coming up next will be ground gas closeouts at the launch pad. Looking at the T-minus 1 minute mark, Falcon Heavy will enter startup, and the onboard flight computers will take over the launch countdown.
Ground gas closeouts.
The increase in white cloud and the venting that you hear is a nominal part of ground closeouts, and it comes from venting down the TE liquid oxygen fill line. We're now standing by for Falcon Heavy to enter startup.
Falcon Heavy is in startup.
Stages 1 and 2 will now begin to pressurize for launch.
Hold, hold, hold. Hold, hold, hold.
Launch abort is running.
As you just heard, we did have a hold in the countdown. We're standing by to get a little bit more information on the nature of the abort. As you heard on the nets, it looks like we will be standing down from today's launch attempt due to weather. The vehicle and payloads remain in good health, and our next launch opportunity is tomorrow at 10. As always, thank you so much for watching, and we hope to see everyone back here for our next attempt.